In this video, I'll be solving a handful of problems from exercise 3, 6.2. That's 6.2 exercise number 3. Before I jump into the first problem, let's be sure to make note of the directions. You'll see directions quite similar to this on the test, so they're quite important. The directions read as follows. Determine the truth values of the following symbolized statements. Let A, B, and C be true, X, Y, and Z be false. Circle your answer. So the directions here have defined the truth value of all the variables that we'll encounter in this particular exercise. So to begin a problem, I just simply copy it down as it's given to us in the text. I've gone ahead and done that here for our first problem. Number 1, we're given A and X. So that, again, is the first step. Just simply copy down the problem as it's given to us in the text. Once we get going on this, many of you will actually be able to skip this step, going straight to the second step. The second step is to plug in the truth values of all the variables as defined for us by the directions. Again, the directions tell us that A is to be defined as true, so I'll plug a T in directly underneath the A. The X, as indicated again in the directions, is to be defined as false, so I'll plug in an F directly underneath the X and copy down the operator, the only operator given to us in the problem. So A and X, as indicated by the directions, is to be defined as T and F. The last step in this particular problem, as it's a fairly simple, straightforward problem, is to now determine the overall truth value of the statement. What now is the value of T and F? And if you haven't memorized the truth tables just yet, go ahead and look up the answer in that truth table. The value of T and F, you'll see, is of course false. There's only one way for a dot statement to be true, and that is if both of the conjuncts are true. Here, as defined again in the directions, only one of the conjuncts is true, the first one, the A, and so the overall value we see, again by consulting the truth tables, is that the overall value of the statement is false. So I'll go ahead and abide by the directions by circling my final answer. And that really is all there is to it. Some of the other problems in this exercise are a little bit more complex. They involve many variables and many operators. But that doesn't make it a more difficult problem, that just makes it slightly more time consuming. So let's skip ahead a little in the exercise, and certainly, as always, I recommend that you work quite a number of these problems. First of all, to commit the truth tables to memory, secondly, make sure that you are in fact proceeding correctly. So for now, I'll go ahead and skip ahead to problem number 10. I've gone ahead and copied down the problem as it's given to me in the text. And my next step here is to sub in the values of the variables as defined by the directions. Once again, the directions tell us that A is true, so I'll pencil in a T directly underneath the A, and the Z is defined as false. From there, I'll go ahead and copy down, bring down all of the operators as well as the parentheses. So by plugging in the truth values, we need to now solve for not parentheses T and not F close parentheses. So how do we go about doing this? This is much more complex as compared to problem number 1. One just had a single operator, and here we've got two tildes as well as the dot. So what's our operating procedure? Well, we always, when there are multiple operators, we always finish with the main logical operator. So it's quite important here that you correctly identify the main logical operator. If you make a mistake in identifying the main logical operator, then the rest of the problem will be incorrect. So the main logical operator here, quite obviously, is the tilde, as the tilde comes on the outside of everything. So we'll tackle that tilde last, and for now, ignore it. That now just leaves us with the inside of the parentheses. So just taking a look at the inside of the parentheses, what now is the main logical operator? The main logical operator of the inside of the parentheses is, of course, the dot, so that will come second to last. And that now just leaves us with the tilde. So we'll begin the problem by solving for the tilde. What's the value of not false, not F? Well, not false probably makes pretty good sense. Not false would be true. So that's my next step. I figured out the value of not false, so I wrote a T directly underneath that particular operator, and I'll go ahead and copy the rest of the problem down. So we've solved for that tilde, that's taken care of, which gets us down to not T and T. The main operator is still the tilde on the outside, so we'll take care of the inside of the parentheses first, and there's only one operator here. What's the value of T and T? Well, this is the special case for the dot. Only one way for the dot to be true, and that's when both conjuncts are true. That's exactly what we have here. So the value under the dot is the t. That turns out to be a true statement. So now we just need to carry down the tilde, and one more step to go. What's the value of not t? Well, not true, of course, we just flip it. Not true is false, and that's our final answer. So I'll go ahead and circle it. So that's problem number 10. Slightly more complex as compared to number 1, but just take it one step at a time until you catch on here, until you get the truth tables down, and then certainly you can pick up some speed, which I highly recommend, might very well come in handy come test time. So that's problem number 10. I'm going to skip ahead all the way to problem number 20. Problem number 20 is one of the longer problems in this section. And I've gone ahead and not only copied down the problem as it's given to me in the text, but I've also gone ahead and plugged in the truth values for x, z, b, c, and a, respectively. So same exact procedure as compared to problem number 10 will apply in problem number 20. Let's begin by identifying the main logical operator. The main logical operator is this second horseshoe. It comes between the two major groupings. Everything on the left-hand side here contained in parentheses, and everything contained here on the right side in the brackets. So I'll take care of this last. From here, I need to solve for the left-hand side and the right-hand side. And it doesn't make a lick of difference which side you do first. I tend to work left to right, but if you'd like to start over here, that's fine as well. So let me just take care of the antecedent, and I'll ignore the rest of the problem for now. What's the value of f horseshoe f? Well, again, consult your truth table if you haven't committed them to memory just yet. There's only one way for a horseshoe statement to be false. That's when the antecedent is true and the consequent false. That's not this special case. So the value of f horseshoe f, we can know, is true. So that takes care of the antecedent in its entirety. I now just have to solve for the consequent. The consequent certainly is much more complex. So let's identify the main operator of just the consequent. The main operator here is, of course, the dot. So I'll do that part last in just solving again for the consequent, meaning that I need to solve first for the first conjunct and then for the second conjunct. No real particular order here. You could work right to left if you like, but again, I tend to work left to right. So let's just focus in on that first conjunct here of the consequent, for now ignoring everything else. The first conjunct is t triple bar not f. The main operator here, of course, is the triple bar. So let's take care of that tilde first. What's the value of not false? Well, not false is true. So we get down to t triple bar t. The values are the same, so t triple bar t, look it up in your truth table, that turns out to be true. Now the second conjunct. The main operator of the second conjunct is the tilde, so we'll take care of that last. Solving for the wedge first. T wedge t, well that's true. So what's the value of not true? Well, not true is false. So we get down here comparing the first conjunct of the consequent to the second conjunct of the consequent. We get down to t and f. The value of t and f is of course false, which leaves us now to solve for the main logical operator. We get down to t horseshoe f. That's our special case, so 20 turns out to be false. And that's all there is to it. If you can make it through 20, you're in good shape. I would recommend going ahead and giving 25 a shot, just to make sure that you can handle it.